Chapter 12, Patient Safety and Proactive Risk Assessment. This is a summary where the original chapter authors were Carlson, Fay, Hunt, Karsh, and Wetterneck, all from the University of Wisconsin-Madison. This was a fun chapter to discuss patient safety and the concept of proactive risk assessment. It's something I would like to look into in more detail in the future. It starts by discussing some of the techniques of patient safety and proactive risk assessment, and shows how risk assessment can help us understand the complex nature of healthcare environments. The patient safety paradigm posed has three components. First, reduce healthcare professional errors. Second, reduce patient injuries, including near misses. And third, improve evidence-based medicine to create higher quality and safer care. They suggest a safety engineering paradigm where there's again three components. The first is creating safety in design of the products, processes, and systems. The second are proactively identifying, eliminating, and reducing hazards. And the third is when an error or harm does occur, that the cause needs to be identified. And a hazard is anything that increases the probability of errors or of a patient or injury employee. Moving more specifically into proactive risk assessments, there are many different tools that one can do to undertake a proactive risk assessment. One is root cause analysis, which is actually more of a retrospective technique. The one that the text focuses on, FEMA, an FMEA, or Failure, Mode, and Effect analysis, identifies all the steps or modes, aka the ways that something can fail, the FM, failure mode, and then studies the EA, the effects analysis, and looks at the consequences of what happens when those modes fail. And the third suggested is a probabilistic risk assessment. And this is more of a higher level, systems level, prospect analysis, where you try to compute the actual risks attributed to the errors in a process. We'll now go through an example workflow for a proactive risk assessment. There's three components. There's a setup, an actual doing, and then a looking at the results. In the setup, we identify the safety objective to study, the scope, and the assessment, and make it very clear. Because there always can be other things to study outside of this scope. Second, we identify the process which is going to be studied, and it's very important that the process is actually the real work which is happening day to day on the floor, and it's not the prescribed work or the work which we think that people are doing or the work that people should be doing. There's often a difference. And really the only way to get the real work is to involve people in this process which are doing the tasks themselves. A third part of setup is to identify the context, the setting, and organization where the study objectives and processes is going to take place in and be studied. And then we'll prepare the resources needed to actually do the risk assessment. When the risk assessment is undertaken, the general steps are first, make sure that an actual methodology is used, such as failure mode effects analysis or one of the other many ones. Second, make sure you have all the right participants. You want a wide team with everyone who's involved or related to that process or affected by it. Three, you want to establish how often is the group going to meet, what is the process which is going to be studied, how long is that process going to be studied for, who's going to study it, and how. Then once the process has been studied, they need to identify all the failure modes, the impact of each failure, the severity of the failure, the contributing factors to the failure, and consider running simulations to help really identify all the failures in the potential process, and then to consider the short and long-term solutions to that failure and what the recovery process is. And then to study this process and look at its results, establishing up front who the researchers are going to be, what type of scoring system they'll use to identify if this has been a success, and to look proactively and see how the risk assessment can be evaluated to see when risks do occur. Some examples that are given, for instance, was a new IV pump was going to be introduced, and the group in the chapter found that there were 38 steps as part of hanging the medications and administrating them, and they identified 200 possible failure modes in this process. And the failure modes were then categorized into one of 5 components, such as, can it be addressed by using policy and procedure? Can it be addressed with training and education? Does this affect the environment, the people, or the technology, hardware, and software? And so the hope was that using one of these 5 instruments, that each of those failure modes can be mitigated. Policy and procedure, training and education, changing the environment, training of people, or fixing the technology, hardware, and software. A second example in the book is presented where during the risk assessment discussion, many risks and concerns came up which were outside the scope of the specific risk assessment which was being performed. And the way that this was addressed was they had a concept called the parking lot, and all the other ideas were placed onto that board to be discussed at a future risk assessment. So this is the chapter as written. Later on, I would like to write another post looking more specifically at failure mode effects analysis, which I believe comes out of military or aviation circles, and a little bit more on its origin and the actual process in detail.